And welcome everyone. Thank you for attending this second session about Kubernetes. Today we're going to do a bit more stuff than Monday. I hope you enjoyed the session on Monday. And today I will do a quick recap. So to put things fresh in mind for everyone. And again, please let me know in the chat if the sound is okay, because streaming is always complicated. I depend on the network, on my hardware, so I hope the sound is good. I know we had some sound issues on Monday at the end of the stream. I really hope it won't happen again and that my video and sound is synced. That is the new issue that I experienced. Okay. Okay, let me put the chat there. I keep an eye on the chat. Sound is okay. Thank you, David. I see a lot of people here today. Great. Okay, let's go. So let me go to the slides here and let me go to presentation mode. Again, let me share some stuff with you before the survey. Like Monday, I had a survey. Now I have a new survey. So please take some time to fill it in. It takes you a minute or two, and it really helps us. Okay. The link to the slides of today and the link to the tutorial, which is the same tutorial as Monday, because everything is there. Okay. There we go. I can close this. Okay. Few words about the agenda. We are already here. Kubernetes Elementary. So there are only 2 master courses left for August. Next week, Monday, is Istio about service mesh. And the Wednesday after will be about Knative, the serviceless solution for Kubernetes. So I really advise you to sign up for these courses as well. Okay. The survey, I already shared that with you. For those that were not there on Monday and that don't know me, I'm Sebastien Blanc. I'm your CodeCaster today. You can follow me on Twitter. You see my handle here. I work in the developer advocacy team at Red Hat, and I enjoy it a lot. And enough speaking about myself. What are we going to talk about today in this second part of the course? Okay, so we will do a quick recap. So we see all the concepts that we covered, like deployment, services, scaling, stuff like that. Okay. Once we have done that, we will spend a bit of time on how you build images, because that's the most important part. Your pod contains a container, and you need to build that container image of your app. So it won't be a Docker course today, but I just spent a few minutes on how to build a Docker container and some common mistakes that you can make if you are building containers with Java applications, for instance. Okay. Then we will speak about resource limits, because Kubernetes is really good at scheduling your workloads, but you have to help him to say, okay, my app takes so much memory, so please find a node available with enough CPU, enough memory, and etc. Okay. Then we will speak about rolling updates. I think I will skip this because we already covered that on Monday. A really important point is the live and readiness probes. Again, you need to help Kubernetes a bit. You need to tell Kubernetes when your app is ready to serve requests, or when it is dead, when you have a memory leak. So Kubernetes can take actions, restart your pod or kill your pod and create a new one. And it's pretty easy to do. But again, it's a really important thing to do. And we will see that together, how to do that. And we will end with environment variables and ConfigMaps. Okay? So let me see. Quick recap. And for the quick recap, I just go straight to the console. Okay. So what did we saw on Monday? We saw that we are using the command line called kubectl, and that we always start by creating a namespace. Okay, so let me create a namespace, and let me call it my space, for instance. Okay, and then we go into this namespace. I'm using my plugin to not have to type the whole boring stuff to go into a namespace. My space. Okay, and there we go. Again, let me start here a watch on my pods. Get pods. Okay, there we go. There are no resources, which makes sense. Okay, and what we're going to do is to apply a file that is a deployment file. And let me show you that file over here. We're going to deploy a Spring Boot application. So it's a kind of deployment entity. Okay, we call it myboot. I want to run replica. I put some labels on it, and here I specify which image I want to use and which port I want to expose. Okay, resources, that is something that we will see later in this course. Okay, so I will just apply this file. And how do I apply this file? I do a kubectl apply -f for file, and I point that to my file. And this one is called myboot resource limits. Okay, and there we go. And that will create a deployment for me. And the deployment will create a replica set, and the replica set, you can see it here, creates a pod for me. Okay. Now we want to expose that service so that we can communicate with it from the outside. So I will create a service for this. Okay. And again, let me show you the service, how it looks like, myboot service. So it's a really simple YAML file, as you can see here. It's of the kind service. It's called myboot. And again, the most important thing here is the selector. That means that it will pick any pod that has the label myboot, and it will take it under its umbrella. Okay, and we want a type load balancer. That's all I need to do. And again, I do kubectl apply /f myboot service, and there we go. And that will create the service for me. Okay, we can make sure we have the service get service. Okay, and we can see here that we have a public IP. And you remember Monday, it took some time before Amazon resolved this public IP. So let me just start a poller here. So let me do this, and I do a while true. Do curl, and I need here to put this. Okay, let me double check. No, I made a mistake. A typo here. Do curl. Okay, so I'm curling this endpoint forever. I do a small sleep, and I'm done. Okay, so the host is not resolved. It will happen in a minute or two. Okay, but what we can do until it gets resolved is again take a look at the pod here. And you remember we also saw that we can do several things. We can, for instance, go into the pod itself. Okay, so let me go into the pod with kubectl exec, and I want to open a bash in this pod. And now if I do a curl localhost 8080, I should have a response. Aloha from Spring Boot. Okay, let me exit this. We also saw that we can do kubectl logs. Logs, exactly, yes. And here we see the logs of my app when it starts. Okay, what can we do? I'm trying to fill in the time here until my IP is resolved here. But anyway, well, let's kill our pod. We have one pod running now. Let's go for 3 pods. Okay, so how do we do that? I just grabbed the command here from the tutorial. We have something called kubectl skill deployment myboot replica 2. that means that I want 2 pods now, okay? So I just do this, and if I do kubectl get pods, I got my second pod running, okay? Oh, and there we go, the address is resolved. Awesome, awesome, okay? What we also saw is, since we have a deployment that makes sure of the state of our pod, if I delete a pod, kubectl delete pod, and let me delete the old one here. I delete the old one, okay, and once it's deleted, it takes some time, I have no idea why. It should be straight, okay, what is happening? Why is it taking so much time to delete my pod? Let me break that. Kubectl get pods. Okay. Oh, yeah. Is terminating, but it's taking some time for it to terminate. I have no idea why. Okay. So we see here more or less what we have done. What I want to do now is to make a second deployment. Okay, so let me show you. We are going to deploy almost the same deployment as before, but this one is called myBootNext, and it has the label myBootNext, that is important, and it deploys a Spring Boot application version 2. Okay, it's a different application. So let me deploy this. kubectl apply f, and I go here for my boot, and I go here for v2. Okay, so it is v2 that is getting deployed here. Let me make sure get pods. I should have a pod that is getting created here. Yeah, it's getting created. It takes some time because he needs to pull the image. Okay, let me see if it's running now. Yeah, myBootNext. Okay, and we can just make sure by logging into it that we have deployed the right one. Okay, there we go. And if I do a curl localhost 8080, there we go. We get now not Aloha but Bonjour from Spring Boot. Okay, so we get our second version deployed. But our service is still only picking the first one because we are matching on the label my app, my boot. Okay, so what do we need to do is to change the selector of our service to point to this new version that we have deployed. And this way we can do blue-green deployments, you know? You get one version running, 2 versions running in production, but only one is available for the customers. And at one point you say, okay, we can go over to the new version. And all you need to do is to change the selector in the service, okay? How can you do that? Well, there are several ways. I show you the one from the tutorial here. What we do here, we use a command called kubectl patch. And here we say, go and patch the service definition that we have made, the service myBoot, and change the selector to myBootNext. Okay, and that will change my service on the fly. And if we do that, you see here, instantly we go back, we go to the new version. Okay, how I could do that as well, I could just do kubectl edit service myBoot. Okay, and that will open me the file, and there in this file I can just change it here and go back to the old one. I save it, and at the moment that I exit the file, take a look here, I should go back instantly to the first version. Okay, so again, that is to show you the power of using labels, etc. Okay, that's for the recap. And again, what I showed you here, if you take the tutorial here, in the beginner's part, blue-green deployment. Everything that I show you here is described here, and you can redo that as you want tonight, or you can try it now while you're listening to me. Okay, let me open the chat to see if there are any questions. There are no questions. Okay, awesome. That is not a problem. If you have questions, please drop them there. I will be more than happy to answer them. I don't know if some colleagues of mine are available. Burr was there Monday, but they will be also happy to answer your questions. Okay, let me open the slides. Quick recap. Okay, yes. Okay, so building images. As I told you, you have your Node.js app or your Spring Boot, your Quarkus app, and you want to deploy that to a Kubernetes cluster. And for that, you need to create an image, a container image of it. Okay, and a container image consists of different layers. So the first thing that you will have to do is to find your base image that basically contains your operating system, maybe a JVM, some utilities. Okay, so you can pick them from Docker Hub, from Quay, or if you are a Red Hat customer, we have some clean and really robust images available on access.redhat.com/containers. Okay. Then you have to create a Docker file that describes how your container looks like, and then you can just build your image. Okay. Once you have built your image, you have to push it to a public repo. So it can be on Docker Hub or Cray. It's free. You just create an account and you can upload your container there. Okay. And then, as we saw before, in your deployment, you just point your image to your image like we did here. Let me see, like this. Okay. And if it's available, Kubernetes will just grab this image and run your container. It's that easy. So let's play a bit with that. Let me go here, back, and let me clear this. And let me go to hello world, Spring Boot. Okay, so here I have a really simple Spring Boot app, the one that you saw. Okay, so it's a regular Maven project, and I can just build it. Maven clean Maven clean package. Okay, that will create my image. There we go, and it's down. Oh, yeah, okay, there we go. And then I can just do Java jar, target, and run the jar. Okay, and that will run my Spring Boot application. There we go. And if I go here and that I curl my localhost, we got our Spring Boot app running. Okay, so I built my jar file, and now I want to build a container that will run this jar file. Okay, so how do we do that? Let me close the app here. You need a Docker file. Okay, and we got one here. Maybe let me open this here in code. Maybe that's easier. Later, let me just close this Docker file. There we have a Docker file. Okay, so a Docker file is as simple as this. Few lines, the base image. So here I want the base image that contains the OpenGDK 8. I set some environment variables. I copy my jar. I expose the port 8080, and finally I do my Java jar. Okay, that describes how my container should behave and how it should be built. And how do I build it? Well, you have to have Docker installed on your machine, and then it's just a matter of doing docker build /t, and here I say I want my app to be called query.io, my repo, my app v1. Okay, and this dot here means that my current directory is the one in which I'm. Okay, and I do this. And now it's going really fast for me because I already had all these images. okay? But if it's the first time that you do that, it will take some time, okay? And then I can just run my container, okay? And just because I'm lazy, let me grab that here from the tutorial. Let me see, Docker build, okay? Again, you can see that everything I typed, you can find it back here. And there we go. Docker run, to run this, you just do Docker run, you expose some ports, and you give the name of your app, and you say which tag you want to run, okay? So there we go, I just do this. And again, now it's my Spring Boot app running, but inside a container, inside of Docker, okay? And here, if I do my curl, it just works, okay? So it's pretty simple to build a Docker container, Docker image, okay? I need some water because, again, it's really hot today here. And I want to show you something, because if you remember from our Docker file, let me just show you that. The Docker file that we have here, it's a Java 8, okay? And there's a bug in Java 8. Java 8 is if your Java application asks to the host how much memory it has, it will not retrieve the memory that has been allocated by Docker, but it will retrieve the memory allocated by the host itself. And by default, Docker doesn't get all the memory. So that can lead to some weird situation. Let me show you that. Okay? Let me, once again, let me run the app again, sorry. So let me run the app again. There we go. It's running. Oh, yeah, there we go. And if I get here an endpoint that is called sys resources, I think. Okay, and that gives me how much resources I got. So it says I get 7 gig and 8 cores. Okay, that seems correct. And I want now to call a method that will consume all the memory I have until I reach 80% of the available memory. Okay, I can show you the code of this because it's pretty easy to understand what is happening here. Consume here, this is the method. I just build a string, and once I get to 80% of the memory, I exit the loop and I say, okay, I allocated this. So let me do that. Let me call this consume method. And there we go, consume. And there we go. And it works. And it worked because that's weird. It shouldn't have worked because that is awesome. That's the correct behavior. It should have failed. Let me make sure that I'm running the right container, because maybe I rebuilt it with the wrong JDK. Actually, it should fail. It should go beyond the 80% because it doesn't get the right number. Okay. Let me build this. Let me call it V7, for instance. Okay, there we go. V7, okay, and let me run it. V7. Maybe add old version there. Okay, let me try again. Resources, okay. No, that's going to work as well. So I don't know what happened here. Okay, it worked. It's interesting, yeah, it's interesting. Because the idea is there's a bug in Java 8, as I told you. And here I mentioned that I run on a Java 8. So I was expecting, and until last week, I was expecting this code to fail. Okay, and I was going to show you how to fix it. Well, the easy way to fix it is to go to Java 11, or to use some, if you have to stay on Java 8, to use some experimental JVM flags. Okay, by putting these flags, you make sure it's working okay. But for some reason here, it's maybe because I built the jar with Java. Let me just, I'm curious, Java version. I'm on 11. So I built the jar with 11, but it's running on a GDK 8. Okay. I'm a bit lost here. I don't want to spend too much time on it, but just be careful when you build images with Java. And by the way, you should all be on Java 11 at least. No, Marcello, it's water, believe me. I will be dying. It was vodka now. Okay, so anyway, let me see if no, I think no, I'm okay. I'm okay. Sorry, it was working. Sorry, I'm a bit lost because the problem occurs when you start constraining your Docker container. Okay, that is what I forgot to tell you. So let me do it again, and this time it will work. I'm so sorry about it. So if I do a Docker run and then I say I give you only 400 megabyte of memory and just one CPU, okay? So I'm constraining my app now. There we go. I'm constraining my app, and you will see it will take some time for the app to start, because it doesn't have too much memory now. So it's taking a lot of time to start. There we go. And now it should do the trick that I wanted to show you. Okay, it started. So if I do a curl sys resources, yeah, there we go. Sorry, that is what I wanted to show you. So now we constrain our container. You remember we said we only give him 400 megabyte of memory. And he still sees 7 gig. So there's the issue. So if you do consume, if we do consume, now we should have an out of memory exception, because he thinks he got 7 gigs, but in fact he had only 400. So he's at one point he's going over the limit. Okay, and here we see it's killed. Okay, so that is exactly the Java 8 issue that I wanted to show you. I saw a question here about the options, the Java options. So let's do that. Let's build the image by unlocking some parameters. Okay, and let me just grab it from the tutorial because it's easier. There we go. Let me get that so I can show you Docker memory. And so here are the Java options. What I do, I unlock experimental VM options. And here I say use CG group memory limit for heap. Okay, that basically says don't look to the host, but look at the container. And here I print some stuff out. Okay, that's what I do. So let's build this file here. There we go. And basically we unlocked some features. And again, that is if you are sticked on Java 8. Otherwise, just go for Java 11. Okay. application is almost started. There we go. Yes, okay. Now, if I do sys resources, this time is correct. We see 112 megabytes. And that's correct because we give Docker 400 and Docker gives 1/3 of the memory to the JVM. Okay, so that sounds good. And if I do consume here, there we go. It just errors as expected. Okay, so once again, be careful if you have an app that needs to know to play with the memory and that you are sticked on GDK8. That's it for images. Let me go to the slides. Again, you can find everything back here. So building images, I showed you here using Docker. So you have to have Docker, but you have a few other options available. There's some jshift.io. To be honest, I haven't tried that. Jib, which is a Maven plugin. Basically, while you build your application, it also built the container image for you. It's really convenient. You have stuff like source to image. That is with OpenShift, you can directly send the source to your cluster and your cluster will create an image of it, okay? There are some non-Docker solutions as well. Podman is pretty famous. Kaneko from Google. And Buildpack is another way to go. There's also Builda. It wasn't mentioned here, okay? So there are a few different ways of building your images. Do not Java and Docker fill. Okay, that's what I showed you. Let's go for the resource limits. Okay, because as I told you, Kubernetes is really good in to schedule your workloads. But if you don't tell him the resources to use, it will just put your pod on a node, and your pod will be able to use as much as memory and as CPU that is available. And maybe you don't want that because you have other pods, other workloads running there, and you need to share a bit the resources, okay? Let's play with that. Let's go back on our cluster, okay? Let me go back here in cube files. And we are going to deploy. I'm going to show you that where I can put this one here. Why don't use Fabricate? Because Fabricate is getting deprecated, and the new version, the new Fabricate is well, it's what I showed you just before. Is JShift. Let me see. It's JShift. Okay, I think that's the new way, the new Fabricate. Okay. Okay. Resources. Let's deploy again a file, a bit the same that we did before. My boot app, so you recognize here exactly the same things, except that we have now a resource block, and here we put a request. Okay, and the request says, okay, I just need 300 megabytes of memory, but I need 10 CPUs, which is huge. I already know that my cluster doesn't have that for him, okay? But let's try to deploy that. Let me get pods. Let me first clean the things. Get deployment. Okay, so kubectl delete my delete deployment, my boot. Okay, I delete it, and I delete next. Okay, so we start with a fresh state. Get pods. I should not have any pods. They are terminating. Okay, and again, let me here listen to some pods. Watch kubectl get pods. There we go. They're still terminating. I don't know why it's taking so much time to terminate these pods, but anyway. And I want to apply this file that I showed you that wants to have 10 CPUs, okay? Which is a lot. I think it's this one. Okay, everything is deleted. And there we go. And now I'm going to create my deployment. And there we go. And look at my pod there. The status say pending. It says pending because it cannot find a node available with 10 CPUs. If I do a kubectl describe pod, this one, I should see here, yeah, exactly. Failed scheduling 0. I have 0 nodes available. Where I have enough CPUs. Okay, so it just stayed here on pending. So what I need to do, and trying to come back here, resource and limits. There we go. Just trying to follow if I'm not missing any steps here. Delete. Okay, get pods pending. That's what we saw here right now. Okay. And now, so let's delete. Let's delete this. kubectl get deployment. It's called my boot again. So yeah, easy one. Delete my boot. Deployment my boot. Okay. And there is deleted. And this time we will create another deployment. And let me show that to you here, where we have exactly the same, but this time we have smaller request to say, okay, please, I need 300 megabyte and a quarter of a CPU. And it could be that during that I'm running, I need to use a bit of more memory and CPU. But I want to limit that. So I can go until 400 megabyte of memory, but and I can go until I have 1 CPU. But if I go beyond that, then Cube will stop the pod. Okay? So let me deploy this now. kubectl apply. It's my boot, and this one is called resource limits, and there we go. Oh, I forgot /f. There we go. And this time it should be scheduled without any issue. Okay, container creating, and it's running. Okay, and if we describe this pod, kubectl describe pod, we can see it has been successfully. Oh, that's so hard for me to say in English. Successfully assigned. But I want to show you if we can see the limits here. You see requests, CPU, and just above you should see the limits as well. Okay, so we know that this pod will behave good until it reaches 1 CPU usage. Then it will go back in pending mode. Okay. Let me see. No questions. That's great. The stream is still working, which is important. So that is the resources. Please take some time when you create your workloads. It's really hard it's really hard to know exactly how much memory your app needs. So the good thing to go is with pretty high requests and limits, and then slowly go down. And maybe the operation team can help you have some tools. Mural asked me if I can do a kubectl get top. Sure. Let me kubectl get top. No, it's kubectl top, I think. Top pod, I think I can do that. Okay, you see? I can also do top node, I think. Exactly. So I can do kubectl top node, for instance, and that gives me how much memory CPU usage I have. Okay. Will it die after requesting more than one CPU? Yeah, the scheduler will unschedule it. Okay, so you have to be careful about this. Is there a top fly command for the pod? Yeah, that's what I showed you just here. Pod, top pod. Okay. Well, here there's no usage on it, but if I would spam again it, I would have some CPU load here on it. Okay. Let me see the time. We are good in time. I want to spend some time now on so resources, really important. I told you, yeah, running updates. We already did that in the recap and on Monday. So I don't want to lose too much time on this. You can play this with this at home because I want to spend some time on liveness and readiness. Again, these are important things to take care of. Kube is really smart, it's really powerful, but you have to help it. You help it by giving resources, and you will help him by providing liveness and readiness probes. Okay? Because Kube could think that your app is started, but in fact, your app is still retrieving some data, some initialization data from a database, and it's not ready to serve request. And it could be dangerous. Well, not that dangerous, but if you have a service running for that pod, the service could start serving requests from this pod, and the users will have errors because the pod is not still ready. Okay. Same thing is you have an app and you have a memory leak, for instance, but your app is still running, and Kube thinks that your app is still running, but it's not responding anymore. So that is also why you should have liveness probes. That's every 10 or 30 seconds. Kube just asks to your pod, hey, are you alive? Are you not alive? Okay. So let's see how to do this. Let me do that with. Let me do that. I'm just thinking if I delete. Yeah, let me delete kubectl delete deployment man boot. So we start with something fresh. Okay. So how does it work? Again, we are going to use a deployment file here. With the resources. Now you know what a resource is, but we will also provide a liveness probe and a readiness probe. Okay, and basically, how does it work? You provide a path, an HTTP path, on which that tells to Kubernetes where it should ask for liveness and where it should ask for readiness. Okay. So for now, the liveness, you can see we are just asking at the root of the app. So if the app gives a response, we assume it's live, okay? And for the readiness probe, we go on something called health. And then you can set some initial delay because you know that your app takes some time to start, so it doesn't matter if you don't ask it in the 10 first seconds, and then you want to ask every 3 seconds. Okay. So let me deploy this. I can grab it here, and that should work. Let me see. Okay, and that should deploy again an app. Okay, that deploys an app. Awesome. And let me go into one of this app, execute. There we go. I'm in my app, and if I do curl localhost 8080 Aloha from Spring Boot. Okay, so it's working perfectly. What I can do now is let me show you the code, because it will make more sense if you see the code. Where is the code? The code is here. So for the readiness, so to know when the app is ready to serve requests, we tell Kubernetes to go on this path on health. And what we do here, we just check a Boolean. If it's true, we say, I'm fine, thank you. And if the Boolean is on false, then we return an 501, service unavailable. Okay? And this Boolean, that is, you can set it here with an endpoint called misbehave. So if I go call misbehave, behave will be false, and my health endpoint won't work anymore. Okay, that is just to demo the health probe. So let me do misbehave here. Behave. Okay, now this pod is misbehaving. Okay, and it is this one. And you have to take a look at it. Hey, you see, it's not ready anymore. Because Cube asked to this pod, hey, are you ready? And it said, no, I'm not ready. So you remove it. And if we had a service, for instance, it will be removed from the service endpoints, okay? And if I go there and that I say, okay, I'm checking questions. Is there can it live update the top comment? I mean, I think if you do a watch on it, I never tried it, but yeah. Red Hat is moving away from Docker to Podman. How does the new concept see? Did you know that both Red Hat Linux 8 instances have dropped official support to Docker container runtime images? Yes, it's true. Because of this, you have two choices. Yeah, that's correct. I'm still showing Docker because that's what most people know. And to be completely honest, I haven't played. Which pod? The one that I just misbehaved? I can do misbehave again, do an exit, and do a kubectl describe pod. So that's probably what you want to see. Warning, unhealthy. So here you can see that in the events you get a warning that it is unhealthy. The HTTP probe failed with status code 503. Okay? Yeah, that's the probe error. Exactly. That's what you see here. Okay? Let me make it behave again. Well, it's not that important, but local host 8080 behave. Okay. And I exit here and back to normal. Okay, and now what I want to do is to show you the liveness probe. Okay, so liveness is essentially health check. Yeah, both liveness and readiness are health checks. With the small difference is that you see here with the readiness, if my pod is not ready, it's not destroyed. It's just waiting until it behaves well again, because it could be a big startup time, or it could self-heal, something like that. Liveness is different. Let me show you that right now. Liveness. Okay, so I show you that. Okay. Yeah, I didn't expose it as a service because it takes so much time to get this address. Oh yeah. That was for the endpoints. Yeah, I could show you that because it makes sense. It's correct. Let me just create a service for that. So kubectl expose deployment. It's called my boot. I think so. Oh, already exists. Oh yes, the service already exists. That could be funny. Let me double check that. kubectl describe service my boot. Oh yeah, I created from the previous. Oh, there we go. So here you see we have 3 endpoints, which are our 3 pods here. Okay, and so if I go again into one of my pods, and that I do a curl localhost 8080 misbehave. Okay, it should go on 0 there. Exit. Okay, and if I describe my service again, now you can see I only have 2 services. Okay, awesome. Let's go for liveness. So this was for readiness. Liveness. Okay. Here I need to. Here I update an image. Okay. Not sure why we are doing this, but let me do it. So here I roll over a new image. My boot version 3. Okay. And oh, I think I'm out of resources. Awesome. You see here the pending state. It could be that I'm running out of resources. That would be funny because I just mentioned that before. Describe describe pod. Oh yeah, I don't have enough CPU. Oh, that is not cool. Why is that? Yeah, usually I have more nodes on my machine, but I thought it would be enough. Okay, not a problem. Let me roll back 2v1. Okay, let me go back 2v1. There we go. Okay, should work. Liveness. Let's go into a pod here. This one, the latest one. Cube execute, and I'm going to call this time another method which is called shut, and where I basically shut my pod. Okay, I said if you get a request, say I have been shut. Okay, so and that is not going to work for now because I haven't set the liveness probe, the live probe. Okay, so I first need to do this. Whoop. Okay. One moment, please. I first need to go into my deployment, kubectl edit deployment my boot. Okay, there we go. And I have to set the liveness probe exactly, because I set the health probe here, but I didn't set this one. So here I set alive. Okay, there we go. That should redeploy all my pods with this setting. Okay, and I hope he will be able to do that because I'm running out of resources. Let me see if I can make some space here. What for namespace do I have that I could fun stuff? Oh yeah, maybe I can delete. Let me just kubectl delete namespace fun stuff. Okay, that will make some space. You see, at the moment that I delete my other namespace, that gives more resources to my cluster, and now it's able to deploy my update. Okay, there we go. Awesome. So this one, this pod here is the new one that has the liveness probe. Okay. If I do a kubectl describe pod, I should have a liveness probe set liveness. Okay, alive. Okay, awesome. So we're almost there. kubectl execute. Let's go into this pod. So we go into this pod, okay, and take a look here. I have been shot. I should go out of the pod because it should not be responding anymore. Okay, let's wait a bit because I think there's 10 seconds between each request. There we go. I have been shot. Yeah, but you're still there, which is weird. Okay. So looks like I have a small demo effect again because I told the pod is shot. And that means that he should not respond to the alive. And that should, oh yeah, you see, now it happened. I've exited the pod because the pod doesn't exist anymore. And he has restarted the pod. We got restart 1. Okay? And it's running again. So that's the difference with the liveness probe. Liveness probe will restart your pod. I got 3 minutes left. That is really short. I won't be able to cover, I think, environment variables and ConfigMaps, which is not really an issue because it's pretty easy to do it yourself. Configure. Maybe we can try to do it. If I go back into this pod. Okay. kubectl execute. Okay, if I do ends, here you can see all my environment variables. And I got a method here, show localhost. Again, all this code is available in the configure, and that will configure some. Here you can see that my pods have only default values for the environment variables. Okay. The nice thing is with Cube is that you can easily set environment variables. You can do that directly in the deployment. You can also do that the imperative style, like you can do it like here. Let me show you it here, for instance. If I go here, I stop it. I can just do kubectl set end deployment my boot and make sure that greeting has the value namaste. Okay, and that will create an environment variable for my pods. Let me see kubectl get pods. Running, okay, pending. Oh yeah, and now you want to deploy again, but I won't be able to show you that because I'm running late in time and low on resources, and it will take a lot of time. But basically, you can go through that. It easily show you how you can set environment variables, and that's it. Let me see if there are questions. Liveness. What is the difference between liveness and readiness? It's not necessarily Yeti. Thank you, Carol. Carol, that's a good answer. Okay. That's it for me. Again, sorry that I could not handle the whole part, but again, you can do it on your own. It's pretty easy to follow. You can just copy paste the commands. You can go even further. We have all stuff about secrets, operators, volumes, taints and affinity, daemon sets, awesome stuff. That is homework for you, okay? And again, you can follow me on Twitter, ask me questions, send me an email. We'll be more than happy to answer these. I go back to my slides because we are almost done. Yeah, there we go. Again, I showed you that on Monday, but once again, if you go on the slides, you have a lot of free resources. ECO, microservices, Kubernetes patterns. I really advise you this one. Knative cookbook, that are all free books. You just have to go on the site to register and you can grab them for free. Okay, so I really recommend you to go there. Thanks for the session. Will there be an intermediate and advanced session? Yes, we are working on that. That's why you saw this new section on the tutorial. And I'm not sure when we will start, probably in September. So keep an eye on the Deaf site and on my Twitter account. But yeah, all these new features, daemon sets, persistent volumes will be covered in a third master course. Okay? I hope you enjoyed the course. And I probably see you, well, in 2 weeks we have something special happening. I can tell you what exactly. Something really cool. It will be live as well. It's not a master course, it's something different, but you will hear more about that. And so I'm working hard on that right now. But next week there's Istio and Knative. It will be done by Edson, I think. And until then, I wish you a really nice day and see you next time. Bye bye.